Okay, so in this video we're going to go over an example using bearing. In this case we have an application problem. So here for our problem we have the course for a boat race starts at point A and proceeds in the direction of south 52 degrees west to point B. Then in the direction south 40 degrees east to point C. And finally back to point A. All right. Point C lies 8 kilometers directly south of A. Okay. All right, so here, let's see here. So the hardest part here is always where to get started, right? So I know we have some kind of boat race. We start off at point A. And then from here, and actually we know point C is directly south, right? And that is 8 kilometers. Okay. So that part is given, right? So finally back to point A, point C lies 8 kilometers directly south to point A. Now, the race goes from A, B, C. So let's see how we get to point B. The course for a boat race starts at point A and proceeds in the direction of south 52 degrees west, right? So south and then 52 degrees west, so in this direction here. And point B lies somewhere here. All right. And then in order to get to point C, right, and the reason I know it's like somewhere here and let's say not all the way down here, because in order to get to point C, I still head with a bearing south, right? South 43 degrees east. Excuse me, 40 degrees east. So we have here south with a bearing of 40 degrees. Oops. Should use the ruler, excuse me. 40 degrees east. All right. Okay, so we'll assume that's a nice straight line there. Okay. All right, so we have this setup here, and they asked to approximate the total distance of a race course to the nearest thousandth of a kilometer. Okay, well, I know one distance, right? So the distance would be essentially the perimeter of this triangle. This length added to this length added to this length. All right, so again, we'll use the same kind of naming system. So this is C, lowercase c, right? This would be lowercase a, lowercase b. Right, so here this is my angle beta, this is my angle alpha, and this will be my angle gamma. Okay, so right away what I'm given here, right, I know alpha is 52 degrees. Okay, so that one is just straight from the diagram here. Now, I do know another angle, all right, that I can find right away because of parallel lines, right? Remember the ones that are heading vertical in the north-south, like this one here and this one right here, right? Those are parallel, so that means that if this is 40 degrees, then this is also 40 degrees. So gamma is 40 degrees. Right? Oh, and now that gives me beta, right? Beta right away we could see, all right, the sum is 180 minus 52 degrees minus 40 degrees. And what do we get there? 180 minus 52 minus 40 is 88. 88 degrees. Okay, so I found all the angles in this triangle. All right, again, here, just a word of advice when working through this, please draw yourself this diagram. All right, if you're trying to visualize this in your head, it's not going to work. There's too many parts going on. Right, so when I see these bearing problems, I want to see this diagram here. Right, that way at least you're communicating to me what you're thinking in terms of the problem. Okay, So I know a length of a side, right? So here, recalling the law of sines, let's say I wanted to, let's start finding side C. Okay, so that means applying the law of sines, we have sine gamma over C. And here I'll use the other piece of information that I do know is the known side, so 8 and the angle beta, so that'll be sine beta over sine beta. All right, and then I'll plug in what I know, right? Sine gamma is sine of 40 degrees over C, unknown, sine beta, which is 88 degrees, over side B, which is 8. Right? And again, from here, cross multiply, so C sine of 88 degrees equals to 8 sine of 40 degrees. Right? And again, I'll hold off plugging anything in until the last step. Okay, and now we take our calculator out. Excuse me. And here we'll have 8, double check mode, degree. Yep, 8 sine of 40 in the numerator divided by sine of 88. All right, 5.15 for we're doing the nearest hundredth. And again here, we have an application problem. So units are important. So 8 kilometers, so same units is kilometers. Okay. All right. So now we have side C. Now let's focus on side A. So I'll still use the ratio sine 40 degrees. Excuse me, let's use the beta, the one that we originally found. Sine 88 degrees over 8. All right, and to find side A, we'll have sine of 52 degrees over A. All right, and from here, same story, right? Cross multiply. So A sine of 88 degrees equals to 8 sine of 52 degrees. Divide by sine of 88. Here we have A is equal to 8 sine of 52 degrees over sine of 88 degrees. Plug that into my calculator. Again, in using the calculator, let's bring the previous entry back, and all we need to do is switch the 40 degrees to 52. Hit enter and round it to the nearest hundred. It's 6.31. So A is 6.31 kilometers. All right. Now here, we're not done, right? We weren't asked to solve the triangle. We were asked a very specific question. So always go back and see, right, what was I asked? The total distance of the race, right? So we have to add up all these sides. So total distance. So we use capital D for distance. The initial 8 kilometers that was given to us, the 5.15 we found, and the 6 and 3100ths. All right, so 8 plus 5 and 15 hundredths plus 6 and 3100ths for a total distance of 19 and 46 hundredths. And again, units, right? 1946 what? Feet, centimeters, in this case, kilometers. Okay, and that's how we solve a bearing problem.